Hello there, and welcome to Sleep and Learn. Tonight, we journey through the quiet vastness of space. We explore the mysteries of black holes and the fabric of space-time itself. These cosmic wonders hold secrets about the universe, and they invite us into a peaceful contemplation. Take a slow breath in, hold it gently, now release. Let your body sink deeper into comfort. There is no hurry. Tonight, you will learn as you drift. You will discover as you rest. Let's begin. Black holes are among the most mysterious objects in the cosmos. They exist in the silent depths of space. They are places where gravity becomes so strong that nothing escapes, not even light itself. Yet despite their power, they inspire a sense of calm, a sense of the infinite. Throughout this hour, we will explore these cosmic mysteries together. We will move slowly through the concepts. Each fact will settle gently in your mind. You do not need to remember everything. Simply let the words wash over you. Let them guide you toward rest. Black holes teach us about the nature of space and time. They show us how the universe bends and curves, how matter and energy dance together in the cosmic dark. These are not alarming phenomena. They are natural, ancient, part of the grand design of existence. As we explore them tonight, you will feel yourself drifting. The vastness of space mirrors the vastness of deep sleep. The silence of the cosmos reflects the silence of peace. Allow yourself to float through this journey. There is nowhere you need to be, nothing you need to do. Simply breathe. Simply breathe. Simply rest. You are safe here in this moment. The universe has been unfolding for billions of years. It continues its patient work, and you can rest in that timeless flow. Black holes begin with stars. Massive stars, many times larger than our sun. These stars burn brilliantly for millions of years. They create light and heat through nuclear fusion. Deep in their cores, hydrogen atoms fuse into helium. This process releases enormous energy. It pushes outward against gravity. For a long time, the star remains stable. The outward pressure balances the inward pull. This balance is delicate, perfect. It lasts for the star's entire lifetime. Our sun will maintain this balance for billions of years. Larger stars burn faster. They live shorter lives, but they shine more brightly. Eventually, the fuel runs out. The core can no longer push back. Gravity wins. The star's core collapses inward. This happens incredibly fast. In just seconds, matter compresses to impossible density. The outer layers explode outward in a supernova. For a brief moment, the star outshines entire galaxies. Then, it fades. The core continues collapsing. It becomes smaller and smaller, denser and denser. If the original star was massive enough, nothing can stop this collapse. The core becomes a black hole, a point of infinite density, a singularity hidden behind an event horizon. Take a moment to breathe. Let that image settle in your mind. There is no rush to understand. Let yourself drift deeper. The event horizon is the boundary of a black hole. It is not a physical surface. You could not touch it or stand on it. It is simply a border in space, a point of no return. Anything that crosses this boundary cannot escape. Not matter, not energy, not light, not information. From outside, the event horizon appears perfectly black. It absorbs everything that touches it. It reflects nothing back. It is darker than the darkest night, more complete than any absence. The size of this boundary depends on the black hole's mass. A black hole with the mass of our Sun would have an event horizon about 6 kilometers across. That is roughly the length of a small city. A supermassive black hole at a galaxy's center might span millions of kilometers, larger than some planetary orbits. But regardless of size, the principle remains the same. Cross the horizon, and you cannot return. Scientists call this the Schwarzschild radius. It marks where escape velocity exceeds the speed of light. Since nothing can move faster than light, nothing escapes. This creates the absolute darkness we associate with black holes. Yet this darkness is peaceful, complete, final. Let yourself drift deeper. Imagine that perfect darkness, that complete silence. It is peaceful in its totality, like the darkness behind your closed eyes, safe, restful, inviting deeper sleep. Space-time is the fabric of the universe. It combines space and time into a single continuum. We often think of space as emptiness, as a void between objects. But space is more than nothing. It has structure. It can bend and curve. It can ripple and wave. It is as real as matter itself. Einstein showed us this truth over a century ago. His theory of general relativity revealed space-time's nature. Mass and energy curve space-time around them. The more massive an object, the more it curves space. Imagine a heavy ball placed on a stretched rubber sheet. The ball creates a depression. The sheet curves downward around it. Nearby objects roll toward this depression. They follow the curves in the sheet. This is similar to how gravity works. Massive objects curve space-time. Other objects follow those curves. We experience this as gravitational attraction. The Earth curves space-time around it slightly, just enough to keep you on its surface. The Sun curves it more, enough to hold 8 planets in orbit. A black hole curves it extremely. Near a black hole, space-time curves so sharply it folds in on itself. This extreme curvature creates the event horizon, creates the inescapable boundary. There is no hurry to understand completely. Let these ideas float through your awareness, like clouds drifting across a calm sky. Each breath takes you deeper into rest. Gravity is not a force in the traditional sense. It is the curvature of space-time. Objects in free fall are actually moving straight, following the straightest possible paths through curved space. These paths are called geodesics. The Earth orbits the Sun along a geodesic. It moves straight through curved space-time. From our perspective, this looks like circular motion, like the Earth is pulled toward the Sun. But from the Earth's perspective, it is simply moving forward, following the natural curve of space. This is a profound insight. It changes our entire understanding of motion and gravity. What appears as force is actually geometry. The shape of space-time determines how objects move, and massive objects determine the shape of space-time. This creates a feedback loop. Matter tells space how to curve. Space tells matter how to move. Together, they create the dance of the cosmos. Planets orbiting stars. Stars orbiting galactic centers. Galaxies moving through the expanding universe. All following the curves of space-time. All moving along geodesics. Let that settle. Let yourself relax deeper. You too follow natural paths. Natural curves through time. There is no need to force anything. Simply allow. Simply be. Time itself behaves strangely near a black hole. The intense gravity affects not just space but time as well. clocks run slower in stronger gravitational fields. This is called gravitational time dilation. It has been measured and confirmed many times. Atomic clocks at different altitudes tick at different rates. The difference is tiny, but it is real. Near a black hole, this effect becomes extreme. If you could watch someone approach an event horizon, you would see something remarkable. From your safe distance, they would appear to slow down. Their movements would become gradual, slower and slower, each step taking longer than the last. As they reached the horizon, they would seem to freeze. Time would appear to stop for them from your perspective. They would hover at the boundary forever. Red shifted into darkness, fading from view. But from their own perspective, time would flow normally. They would cross the horizon without noticing any change. They would continue inward toward the singularity. This difference in time's passage is real. It is not an illusion. It reveals the deep connection between gravity, space, and time. Take a slow breath. Let time slow for you now as well. Allow yourself to sink into timelessness, into the eternal present, where past and future dissolve, where only now remains. You are safe. You are at peace. Black holes come in different sizes. Stellar black holes form from collapsed stars. They typically contain a few times the sun's mass, usually between 3 and 20 solar masses. These are scattered throughout galaxies. Thousands likely exist in our Milky Way alone. Most remain invisible in the darkness between stars. Silent. Waiting. Occasionally they reveal themselves. When a companion star orbits nearby, matter flows from the star to the black hole. This creates bright X-ray emissions. Astronomers detect these and identify the black hole. Intermediate black holes may exist as well. These would contain hundreds or thousands of solar masses. They might form when stellar black holes merge, or when massive star clusters collapse. Scientists are still searching for clear evidence of these. A few candidates have been found, but confirmation is difficult. Then there are supermassive black holes. These giants lurk at the centers of most galaxies. They contain millions or billions of times the sun's mass. The supermassive black hole at our galaxy's center is called Sagittarius, a star. It contains about 4 million solar masses. Despite this enormous mass, it sits quietly, feeding slowly on nearby gas and dust. It does not threaten us across the vast distance. We orbit safely, far from its influence. Finally, scientists theorize about primordial black holes. These tiny black holes might have formed in the early universe. In the first fraction of a second after the Big Bang, they could be as small as an atom but contain a mountain's mass. None have been discovered yet, but the universe is vast. It holds many undiscovered wonders. You can let your mind wander through these scales, from the smallest to the largest, each one equally real, equally natural, equally part of the cosmic design. Let yourself drift deeper and deeper still. Nothing escapes a black hole's event horizon. This includes light itself. Light moves at 300,000 kilometers per second. It is the fastest thing in the universe, the cosmic speed limit. Yet even light cannot escape once it crosses that boundary. Photons moving outward from inside the horizon never make progress. They remain trapped, moving toward an exit they can never reach. This is why black holes appear black. They emit no light for us to see. They absorb all electromagnetic radiation, all wavelengths, from radio waves to gamma rays. Everything vanishes into the darkness. However, The space around a black hole can be very bright. Matter falling toward the black hole speeds up. It accelerates to tremendous velocities. It heats up through friction and compression. Particles collide at incredible speeds. This generates enormous heat. The matter can reach millions of degrees. At these temperatures, matter glows brilliantly. It emits X-rays and other radiation. This creates an accretion disk, a swirling disk of superheated material. The disk orbits the black hole at tremendous speeds, near the speed of light in the innermost regions. The disk can be larger than our entire solar system, yet it orbits a region only kilometers across. Some matter falls in, spiraling down through the disk, crossing the event horizon, disappearing from the universe. Some is ejected in powerful jets. These jets shoot out perpendicular to the disk. They can extend for thousands of light years. The jets shine brightly in radio wavelengths. They carry enormous energy into intergalactic space. This is how astronomers find many black holes. They look for the bright material around the darkness, the intense X-ray sources, the powerful jets. The black hole itself remains hidden, a shadow against the glowing disk. In 2019, scientists captured the first image of a black hole's shadow. It showed exactly what theory predicted: a dark circle surrounded by a bright ring. The black hole resides in the galaxy Mighty 7. It contains 6 billion solar masses. The image required coordinating telescopes across Earth, creating a virtual telescope the size of our planet. The achievement represents decades of work, hundreds of scientists, sophisticated algorithms, and it confirmed what Einstein predicted a century ago. Let that settle. The invisible made visible through its effects. The hidden revealed through mathematics and patience. Inside a black hole lies the singularity. This is where all the black hole's mass concentrates. Current physics predicts it is a point of infinite density, a place where space-time curvature becomes infinite, where all known laws break down. Here, the laws of physics as we know them break down. General relativity and quantum mechanics cannot agree on what happens. Both theories work perfectly in their domains, but at the singularity they conflict. This represents the limit of our understanding, the edge of the map. Ere there be dragons, the singularity is hidden behind the event horizon. We can never observe it directly. We cannot send probes there and receive data back. No information escapes. This is called cosmic censorship. Nature hides singularities from view, protects the universe from naked singularities. Some scientists think the singularity might not be a point. It might be a ring. A rotating black hole might have a ring singularity, or something else entirely. Perhaps a region rather than a point. Quantum gravity might resolve the infinite density. It might smooth out the singularity, replace it with something finite, but we do not yet have a complete theory of quantum gravity. String theory offers possibilities. Loop quantum gravity offers others, but neither is confirmed. This uncertainty is not frightening. It is simply the edge of knowledge, a reminder that mysteries remain. The universe keeps some secrets, holds some truths beyond our current reach, and that is perfectly fine, beautiful even. You do not need to solve these mysteries tonight. You can rest in the unknowing, rest in the mystery itself. Let yourself drift deeper and deeper and deeper and deeper still, into the comfortable darkness of sleep, into the peaceful unknown of dreams. Black holes can merge together. When two black holes orbit each other, they create ripples in spacetime. These ripples are called gravitational waves. They travel outward at the speed of light, carrying energy away from the system. The waves are like ripples on a pond, expanding circles moving outward. But these are ripples in space-time itself. The very fabric of reality oscillates. As energy leaves, the two black holes spiral closer. Their orbit tightens. They move faster and faster, circling each other hundreds of times per second. They emit a characteristic chirp, a rising pitch as the orbit tightens. Eventually, they collide and merge. This happens in a fraction of a second. The merger releases enormous energy, more energy than all the stars in the visible universe emit in that moment. Three solar masses worth of energy, released in 1/10 of a second. Yet this energy is released as gravitational waves, not light, not particles, invisible ripples in the fabric of space. Scientists detected these waves for the first time in 2015. They used instruments called interferometers. These measure tiny changes in distance caused by passing waves. The changes are incredibly small, smaller than a proton's width, 1/10,000th the diameter of a proton. Yet modern technology can detect them. Laser beams travel back and forth in 4-kilometer tubes. Mirrors reflect them thousands of times. Any change in distance affects the light, creates interference patterns. These patterns reveal passing gravitational waves. Each detection tells us about distant collisions, events that happened millions or billions of years ago. The waves traveled across the universe to reach us, carrying news of cosmic dances long since finished, news from the deep past, arriving in the eternal now. There is poetry in this, messages written in space-time itself. Arriving in the eternal now, you are safe, you are at peace. Let yourself drift on these cosmic waves, deeper into rest, deeper into stillness. Time and space exchange rolls inside a black hole. Outside the event horizon, you can move freely through space. You can go left or right, forward or backward, up or down. Space has 3 dimensions of freedom, but time flows in only one direction. You move inevitably toward the future. You cannot stop. Cannot even slow down. Time carries you forward at 1 second per second. Inside the horizon, this reverses in a strange way. The direction toward the singularity becomes time-like. It becomes like the future. You move inevitably toward it, just as you move inevitably toward the future outside. You cannot avoid it, cannot turn back, cannot even slow your approach. The singularity becomes your future, unavoidable, absolute. This is one of space-time's deepest mysteries. The mathematics shows this clearly. The equations reveal this exchange, but it challenges our intuition. We think of space and time as fundamentally different, but they are aspects of the same thing. Space-time. Inside a black hole, this becomes impossible to ignore. The usual rules reverse. What was space becomes time. What was inevitable future becomes inevitable location. We are not meant to understand it fully in this state. Our brains evolved for everyday experiences, not for extreme gravitational fields. Let the strangeness wash over you. Let it carry you deeper into rest. The universe contains wonders beyond everyday experience, beyond human intuition. You can appreciate them without grasping every detail. You can hold them gently, like dreams. Each breath takes you deeper, deeper into calm, deeper into peace, deeper into the restful darkness of sleep. Black holes slowly evaporate through Hawking radiation. Stephen Hawking predicted this in 1974. Quantum effects near the event horizon allow energy to escape. The prediction shocked the physics community. Black holes were thought to be absolutely permanent, eternal. But Hawking showed they slowly shrink. Particle pairs constantly form in empty space. One particle has positive energy, one has negative energy. They emerge from quantum fluctuations. From the uncertainty principle, they usually annihilate immediately, recombining in less than a trillionth of a second. But near the event horizon, something different can happen. One particle might fall into the black hole, the other escapes into space. The black hole captures the negative energy particle. This reduces its mass. The positive energy particle flies away. From outside, it looks like the black hole emitted a particle. This process carries away energy. Very slowly, the black hole loses mass. It shrinks. The smaller it gets, the faster it evaporates. Smaller black holes are hotter. They radiate more intensely. Eventually, in the final moments, the black hole explodes, releases its remaining energy in a flash. But this process takes an enormous amount of time. A solar mass black hole would take 10 to the 67th years to evaporate. That is a 1 followed by 67 zeros, far longer than the current age of the universe. The current age of the universe is only 10 to the 10th years, roughly 14 billion years. Black holes will outlast stars by incomprehensible timescales. They will outlast galaxies. They will be among the last structures in the cosmos, radiating gently into the dark, slowly giving themselves back to the universe. There is no rush. The universe has patience beyond measure. It operates on timescales that make human lifetimes invisible. Yet we can grasp these concepts, hold these impossibly long times in our minds. You can rest in that eternal patience. Let time lose meaning. Let yourself simply be. Timeless, eternal, at peace. Space-time can do more than curve. It can have different topologies, different shapes and structures, different ways of connecting to itself. Some solutions to Einstein's equations allow for wormholes. These are tunnels through space-time, connecting distant regions, or even different times. Shortcuts through the universe. If they existed and were stable, they might allow faster than light travel. Not by moving faster than light, but by taking a shorter path. You could enter one mouth and exit the other, arriving at a distant location without crossing the space between. This sounds like science fiction, and practically it might remain so. The physics allows them mathematically. Einstein's equations permit their existence, but actually creating or maintaining a wormhole might be impossible. It would require exotic matter with negative energy density, matter that pushes gravity away instead of attracting. We have never observed such matter in large quantities. The Casimir effect produces tiny amounts, but nowhere near enough to stabilize a wormhole. Some scientists think microscopic wormholes might exist naturally. Quantum fluctuations could create them constantly, at scales far smaller than atoms, but they would be far too small to use, and they would exist for only the briefest instance. Still, the mathematics shows they are possible in principle. The universe might be more connected than we imagine. Space might fold and connect in hidden ways. Let that thought comfort you. Everything touches everything else in ways we cannot see. Invisible connections span the cosmos. You are part of the cosmic whole. connected to all things across space and time, part of an intricate web, a universal pattern. Let yourself rest in that connection. You belong. You are home. Black holes help shape galaxies. Most large galaxies have supermassive black holes at their centers. These black holes and their galaxies grow together. They influence each other's development. They co-evolve over billions of years. When a black hole feeds, it creates powerful jets and winds. These jets push gas and dust away from the galactic center. They clear out the surrounding region. This can stop new stars from forming. It regulates the galaxy's growth. Without this feedback, galaxies might grow too large. Stars might form too quickly. The galaxy would exhaust its gas supply too soon. The black hole acts as a regulator, a cosmic thermostat. It maintains balance. When the galaxy grows too fast, more gas falls into the black hole. The black hole becomes more active. It feeds more rapidly. Its feedback intensifies. This pushes gas away, slows star formation. When star formation slows, less material falls into the black hole. It becomes less active. Its feedback weakens. The galaxy can grow again. Star formation resumes. This self-regulating cycle has operated for billions of years. It has shaped the universe we see today. The largest structures in the cosmos depend on the smallest, densest objects. Everything is interconnected. Everything affects everything else. Galaxies and black holes. Light and darkness. Growth and regulation. Everything finds balance. You too can find balance. Let yourself settle into equilibrium. Mind and body in harmony. Thought and rest in balance. Tension and relaxation. All finding their natural point. You are exactly where you need to be. Perfectly positioned in this moment. At peace. The information paradox puzzles physicists. Information, in physics, cannot be destroyed. This is a fundamental principle, a conservation law. Everything that enters a black hole carries information about its structure, its quantum state, its history. But black holes evaporate. They disappear through Hawking radiation. So where does the information go? Does it disappear with the black hole? That would violate a fundamental law. Quantum mechanics forbids information destruction. Does it escape in the Hawking radiation? That seems impossible because the radiation appears thermal, random, uncorrelated with what fell in, like the radiation from any hot object. This paradox has challenged scientists for decades. Many solutions have been proposed. Perhaps information does escape in subtle correlations too delicate to see locally, but present in the radiation as a whole. Perhaps it remains somehow at the event horizon, encoded in microscopic details. Perhaps black holes leave remnants when they evaporate, tiny particles containing all the information. Or perhaps we need to revise our understanding of quantum mechanics, or general relativity, or both. The question remains open, an active area of research, thousands of papers written, conferences held, debates continuing, but it does not threaten the peace of this moment. Some questions await answers, some mysteries persist, and that is part of the beauty of existence. Not everything is known. Not everything is solved. There is still wonder in the world, still puzzles to contemplate. You do not need to solve every puzzle. You can rest in the mystery. Let your thoughts slow. Let your mind quiet. Deeper and deeper still, into comfortable unknowing, into peaceful rest. Black holes spin, Most of them rotate, nearly all of them. This spin comes from the rotation of the matter that formed them. Stars rotate. Galaxies rotate. Everything in the universe has some angular momentum. When matter collapses, it conserves angular momentum. This makes the black hole spin faster and faster as it contracts. Just as a figure skater spins faster when pulling in their arms. Some black holes rotate at nearly the maximum possible rate, nearly the speed of light at their event horizons. A spinning black hole drags space-time around it. This is called frame dragging, or the lens-stirring effect. Space itself rotates near the black hole, gets pulled along by the black hole's rotation. Anything in that region is pulled along. It is like being caught in a whirlpool, a cosmic vortex. The spinning black hole also has a different structure than a non-spinning one. It has two event horizons instead of one, an outer and inner horizon. Between them lies a region called the ergosphere. In this region, space-time rotates so strongly that nothing can remain stationary. Everything must move in the direction of the spin, must orbit the black hole. Energy can theoretically be extracted from the ergosphere. By dropping matter in carefully, you could recover more energy than you invested. This is called the Penrose process, named after physicist Roger Penrose. It would allow civilizations to use black holes as power sources, to harvest rotational energy, though this remains theoretical. For now, black holes simply spin in the darkness, patient, eternal, going nowhere, needing nothing, spending their angular momentum slowly. Over timescales longer than stars exist, let yourself spin down like a slowing top, wobbling, settling, coming to rest, finding stillness, finding peace. Space and time are not absolute. They are relative. They depend on the observer, on the frame of reference. Two observers moving differently through space will disagree about measurements. They will measure different distances, different time intervals, different orderings of events. What is simultaneous for one is not for another. What is past for one might be future for another. But they will agree on space-time intervals. The combination of space and time is invariant, unchanging, the same for all observers. This was Einstein's great insight. Space and time are not separate. They are aspects of a unified whole. Space-time, a four-dimensional continuum. 3 dimension of space, 1 dimension of time, all woven together. In everyday life, we barely notice this. The effects are tiny at ordinary speeds. Our relative velocities are small, but near the speed of light, they become dramatic. Time slows down, distances contract. Mass increases. What seems like minutes to one observer might be years to another. Near a black hole, gravity creates similar effects. Time flows differently at different locations. Clocks tick at different rates. Space curves and warps. Distances become ambiguous. The familiar becomes strange, yet it all follows precise mathematical laws, beautiful equations, symmetric forms. The universe operates according to beautiful principles, symmetries and conservation laws, patterns that repeat at every scale. From quantum particles to galaxy clusters, the same mathematics applies, the same deep structure. You are part of these patterns. Your body follows the same physics as stars and galaxies. The atoms that make you up were forged in stellar cores. Carbon and oxygen and nitrogen, iron and calcium, all created in stars. You are literally made of stardust, connected to the cosmos in the most direct way possible. Let yourself rest in that connection. You belong here. You are home. Part of the universe knowing itself. Black holes connect to the deepest questions of existence. What is the nature of space and time? How did the universe begin? What happens at the most extreme conditions? Does information last forever? Can space-time have different shapes? These are not abstract puzzles. They touch the foundation of reality. Black holes provide natural laboratories for testing our theories. They push physics to its limits. They combine quantum mechanics and gravity, two theories that normally operate at different scales. They reveal where our understanding breaks down. Where new theories are needed, they point toward new theories yet to be discovered. String theory, loop quantum gravity, other approaches still being developed. These attempt to unite quantum mechanics and gravity to describe what happens at the singularity, to resolve the information paradox. Progress comes slowly but steadily. Each generation of scientists adds to our knowledge, builds on previous work. The picture becomes clearer. The mysteries more precisely defined, more sharply focused. You are living in a golden age of discovery. More is known now than ever before. Gravitational waves detected. Black hole shadows imaged. Quantum physics refined. Yet more remains unknown than we ever imagined. Each answer raises new questions. Each discovery opens new doors. Both facts are thrilling. Both invite wonder, and wonder invites rest. The mind that beholds mystery can release its grip on certainty. It can soften. It can let go. It can rest in unknowing. Allow yourself to let go now. Release the need to understand. Release the need to remember. Release tension. Release worry. Simply be present to these final moments. You have learned. You have explored. You have journeyed far. Now you can rest. Now you can sleep. We have traveled far tonight, through the depths of space, through the curves of space-time. We have explored black holes and their mysteries. We have touched the limits of physics and knowledge. These cosmic wonders exist in the silent dark. They shape galaxies and regulate star formation. They bend time and space. They challenge our understanding. They inspire our imagination. And they remind us of our place in the vastness. You are small in one sense, a brief flicker in cosmic time, a tiny collection of atoms on a small planet orbiting an average star in an ordinary galaxy. Yet you are also immense. You contain the capacity to understand these wonders, to contemplate infinity, to ask deep questions, to know the cosmos. This is a profound gift, an extraordinary capability. The universe has evolved for nearly 14 billion years. Stars have lived and died. Galaxies have formed and merged. Black holes have danced their slow dances. All of this has led to this moment, to you, here, now. Consciousness arising to contemplate itself and the cosmos, matter becoming aware, the universe opening its eyes. This is not an accident. This is the universe knowing itself through you. And in this knowing, there is peace. There is meaning. There is connection. Take a slow, deep breath. Feel your body where it rests. Notice the support beneath you, the softness holding you. You are safe. You are held. Let your breathing become even slower, softer, gentler. Each exhale releases a little more tension, a little more holding on. Your muscles relax, starting with your face, your jaw softening, your shoulders dropping, your arms heavy, your legs sinking. Your mind quiets, thoughts drift past like clouds, like stars moving slowly across the night sky. You do not need to follow them. You do not need to hold them. You can simply observe, simply allow, simply rest. The mysteries we explored tonight will remain. Black holes will continue their silent existence. Space-time will continue its gentle curves. And you will continue your journey, rested, renewed, restored, carried forward by the same forces that move galaxies. You are part of the flow, part of the dance, part of the cosmic pattern. There is nothing to fear, nothing to solve, nothing to do. Only this moment of peace, this breath, this heartbeat, this quiet darkness that surrounds and supports you. You are held by the universe, cradled in existence, safe in the cosmic web. Just as black holes bend space-time around them, creating curves that guide the motion of everything nearby, so too can you shape the space around you through your presence and your choices. Black holes remind us that even the densest, darkest places have structure and purpose. They teach us that surrender to gravity is not defeat, but transformation. That letting go can lead to something new. You carry this same power within you, the power to transform, the power to release what no longer serves you and become something new. Even when things seem impossibly dense, impossibly dark, there is a path forward. There is always movement, always change. The universe never stops evolving, never stops creating. You are stronger than you know. You are more resilient than you imagine. You are part of a universe that has been creating beauty from chaos for billions of years, that has been finding order in randomness, light in darkness, and that creative power flows through you too. It is your birthright, your nature. You are at peace. You are exactly where you need to be. You are held by forces greater than yourself. You can rest now. You can let go. You can sleep. Sleep well.